Hello, my name is Michael Proctor. I'm a research scientist, and I'm here to report on a project for Kootenay Connect Year 2 Environment Climate Change Canada Nature Fund project. It's upland and wetland corridors in the Columbia Valley. The Columbia Valley is about 180 kilometers long from Canal Flats up through and past Golden, as you can see in the green outlined area. It has a rich riparian wetland complex up the center, but also on the valley edges and benchlands. And the human disturbance layer is going to be layered on here. You can see the highway. The blue is all the private lands, which are of course centered in the valley bottom. And then each black dot is a house or building in the region. You can get a sense of the concentration of human activity in the valley bottom. And there's the forestry roads on the sides just within the boundary of the area. And this human settlement pattern and development pattern is what has stimulated Kootenay Connect to consider the necessity of wildlife corridors. And this project is about trying to identify multi-species corridors that would work across the valley bottom from upland to upland. And as you can see in a real picture, that there's a beautiful landscape with mountain terrain on each side and the valley bottom down the middle, which is a mix of farms and other settlement patterns. The first piece of evidence I'm just going to go over is the grizzly bear corridors. This comes from my own research from the Transborder Grizzly Bear Project based on 10 years of radio telemetry data, not in this area but nearby, and we extrapolated an estimated habitat, core habitats, and then we used that and estimated corridors. This is a published work, and these are the sort of the finer scale grizzly bear corridors across the valley between Canal Flats and through Golden. Another layer we have is a data-based badger habitat modeling by Nancy Newhouse and Trevor Kinley and others. In the southern half of this region is a rich badger habitat, and we've estimated the corridors based on the pattern in the habitat. It's more a north-south pattern here than an east-west pattern. We also hired Kelly Mulligan, who just finished a master's project using government elk data down in the southern portion of this near Cranbrook. And we hired her to run her model up through the Golden area. And she's a very good student with a very good professor. So her work is done to a very high standard. She estimated elk habitat, and from that we could extrapolate corridors. It was pretty easy, assuming that the elk follow the habitat quality. And you can see there's plenty of north-south corridors and some east-west across the valley. The other layer we have is a Flynn Row, which is the BC government's mountain goat habitat modeling. I have sort of private access to the input data and convinced myself that this model is actually very good. It really predicts where mountain goats live and hang out and use habitat in the areas where they have data. So the extrapolation is pretty good. And that data is pretty close to this, so the extrapolation is pretty valid. I extrapolated the corridors, which basically are the sort of the closest areas that link backcountry mountain goat habitat. The final large mammal layer we have here today is a wolverine density model developed through the work of Flynn Rowe and Doris Hoslander and others who use DNA hits to estimate wolverine density. And they also have a wolverine favorite food model, the marmot habitat modeling, and those are the darker blue patches. And we estimated the wolverine corridors that linked the best patches of higher density and highest food supply. I've discussed this with the wolverine biologists who made the data, and they are comfortable with this preliminary estimate. They are going to do a data-based estimate of corridors over the next 2 years, but now we're just doing a preliminary estimate. When you put all these layers together, large mammals that are good surrogates for understanding large movements, it looks like a big pile of spaghetti, which it somewhat is, but there are some patterns in there, as you'll see in the next slide. I'm starting to find concentrations of corridors up and down that. We don't expect there to be just one or even 3 corridors. We expect there to be many, as there are, because it's a 180-kilometer long stretch, and we can't expect animals to move 50 kilometers just to get across a highway. They're going to cross where it's most convenient for them. So these are the upland corridors that we are going to use to focus and concentrate conservation efforts in year 3 and 4 in the Kootenay Connect Nature Fund project. We have people within our project taking this data to translate it into potential conservation actions, some of which will be to inform the Nature Conservancy, the Nature Trust of BC, and other land trusts for purchasing appropriate projects, as we have done in many other areas, and also other conservation actions. Thank you very much. This is a short little 10-minute quick look at the aspect of this, and we hope that this work will be informing the next 2 years of conservation action in the valley. Thank you very much.